Okay, so let me start with the concept that this is a line with 1 minus 4x. So here's 1. Slope is minus 4, so it's a line that's going downwards. Okay, like this. So let's say that's roughly the graph. And for this limit to exist, what it means is that as x approaches negative 3, okay, so there's negative 3. So let's call this our y value. Okay, so there's the y value. So the distance from y and 13, so here's 13. Okay, so there's y values on this. So if this here is epsilon, right, then you can see that the distance with y and 13, right, would equal to epsilon. So the concept here is that doesn't matter what I pick for epsilon, as long as some small value for epsilon, there's going to be a corresponding matching x value that I can pick. Okay, matching delta value I can pick, so that when I plug in that value, I will get this epsilon. Okay. So algebraically, what that means is that we need to start from here, 1 minus 4x. This is our function. Okay, and subtract 13. We have to start from here, and we need to get to, right, x minus 3 is less than some delta. Okay, and we need to relate our delta with epsilon. So if I can say epsilon is equal to some function of delta, right? Actually, the other way around. Delta is some function of epsilon. This satisfies essentially for every epsilon, no matter what I plug in here, if there's an output of delta, then the limit exists. Right? That's the definition. So that's what we're going for. We're looking for a formula, a delta that's a function of epsilon. Okay, so let's start from here. Let's simplify this. You get minus 4x minus 12. You can factor out minus 4 and you get x, right, plus 3. This is the same as this, which is the same as just 4. Okay, and now we're here, right? X plus 3 is same as x minus of minus 3 is less than delta, epsilon over 4. This implies that delta should be, right, epsilon over 4. Okay, so no matter what epsilons, I can find my corresponding delta, therefore this limit exists.